Welcome back, learners. So as we have said before the ad break that you're going to start with the lesson, and our first concept that you're going to be dealing with is the general chemical reactions. So now let's start to see what do we mean by chemical reactions in general. So a chemical reaction, we need to know, or rather a chemical equation, it consists of the following things. We need to know what it consists of. Firstly, a chemical reaction consists of the reactants. So what are reactants? Those are substances that participate in a chemical reaction, and their chemical formulae are written on the left-hand side of a chemical equation. So we have a chemical equation, then we have the left-hand side and the right-hand side. On the left-hand side, we have the reactants, and those are the substances that are participating in a chemical reaction. And as we have said, they are written on the left-hand side. We also have the products. So those ones, they are substances that are formed in a reaction, in a chemical reaction. Then their chemical formulae, they are written on the right-hand side of a chemical equation. As we have said, chemical equation, left-hand side, reactants. Then that means the right-hand side, those are the products. The left-hand side, they participate in the chemical reaction. They are going to produce the products. So the products, they are produced from the reactants, and they are written on the right-hand side. Furthermore, we also have subscripts. So what are then the subscripts that you're finding in the chemical equation? Those are the number, that's the number that is placed below the symbol of a substance to show the number of atoms making up that particular substance. We have made an example of H2O earlier on to say, this is the chemical formula of water, H2O. Now, the 2 that we're seeing here, that is the subscript. It is written below the symbol of a substance. So it's written below the H to tell us that in this chemical compound, we have 2 atoms of hydrogen. So then obviously, because there's no number that is written below the oxygen atom, there's always a 1. So if there's no number written next or below the chemical formula or below the chemical atom or below the atom of a chemical compound, that means that number is 1. In this case, we have 2 hydrogen atoms and 1 oxygen atom, and that also determines the ratio that is making up the water. In addition, we also have an arrow. So we have the reactants, products, subscripts, and an arrow. Now that arrow, it is our react to form sign. It tells us that the reactants are going to react to form something. So it shows us where the products are going, where the reactants are going to be changing to produce, or where are they going to go when they have now reacted to produce something. Now, as a react to form sign, which is our arrow, it points from the reactants to the products. So in a chemical equation, so the picture is starting to get clearer and clearer now. We're saying that we have the reactants. Obviously now we have the arrow, then we have the products. Now, the reactants, they can have subscripts. Even the products, they can also have the subscripts. Those are the numbers that are written below the chemical substance or the chemical the atom of that chemical compound. And then, in addition to that, we have a plus sign. Now, what is a plus sign now? That one, it is going to separate the reactants. So if we have more than 1 reactant, so if you have more than 2 reactants, those reactants are going to be separated by a plus sign. So it separates the chemical formula of multiple reactants and multiple products. If we have 2 reactants, now 1 reactant with the other reactant are going to be separated by that plus sign. Same thing applies with the products. If we have 2 products or more than 2 or more than 1 products, those products are going to be separated by a plus sign. So now, in a typical example, we can have the first reactant being A, with the plus sign that is separating the 2 reactants. So we have A, the plus sign, and the B, and together they are called the reactants. Why? Because they are written on the left-hand side of the arrow. So our arrow, it is showing, it is pointing from the reactants to the products, telling us what the reactants are going to produce after they have undergone a chemical reaction. Then on the product side, which is on the right-hand side, we have C plus D. We have 2 products that are separated by a plus sign. And together, these things, they are called your products. Now remember, we can also have subscripts on each of these reactants and each of these products. And those numbers are determining or telling us how many atoms of that particular substance are present in that chemical compound. So we can have a 2 there, we can have a 3 there, to tell us that on the left-hand side we have 2 atoms of A, we also have 3 atoms of B. They're going to react together to form C and D. And then we need to make sure that the reactants, or rather the reaction, is balanced. On the left-hand side, we have the same number of atoms as on the right-hand side. And how do we balance? We balance by using the coefficients. Now, coefficients are different from the subscripts. Those ones are written on the right-hand side of the chemical compound as a whole number. So in a case of, if you put in a 4 there, that 4 it's written on the left-hand side of a chemical compound. So that tells us how many molecules of that compound we have, whereas the subscript tells us how many atoms in that compound we have. The coefficient, how many molecules we have, whereas the subscript, how many atoms we have in that compound. So that's the difference between the subscript and the coefficient. In addition to that, we need to know the following: that all chemical reactions can be broken into 2 parts, as we have said, reactants and products. So all chemical reactions, they must have the reactants and they must also have the products. And the other things we know, they're always there, like the plus sign, the subscripts, if any, even the coefficients, if we have the coefficients. Now, during a chemical reaction, the bonds that hold atoms together may be formed or they may be broken. So we're saying that during a chemical reaction, the existing bonds are going to break and new bonds are going to form. By that I mean, the bonds that are holding the 2 oxygen atoms together, they're going to break so that there can be a new bond that is going to be formed. Now, because there's going to be a new bond which is going to be formed, it makes it different from the initial bond, which is now going to be now your CO2. So the bond between the O2 atoms is going to break, and there's going to be now a chemical bond between the carbon with one of the oxygen, and also between the carbon with the other oxygen to form your CO2. Now, as you can see, the arrangement now is going to be different. So the same number of atoms are still there, but the arrangement of those atoms are going to be different. Hence, we need to also balance the chemical reaction to make sure that the number of atoms on the left are equal to the number of atoms on the right. We are then saying all the atoms that were present before the start of the reaction, which are now the reactants, will still be present after the reaction has completed. All the atoms that were there at the beginning of the reaction will still be there at the end of the reaction. However, the arrangement is going to be different. As we can see on the reactants, we have 1 C and then 2 oxygens. But then on the other side, the oxygen atoms are no longer bonded together. There's now another atom in between the 2 oxygen atoms. So as you can see, the arrangement has changed from the initial to the end of the reaction. We're also saying that the properties of the substances produced in a chemical reaction differs from the properties of the original substances. Because we had O2 as a gas, we also had carbon, which is also a solid. Now, at the end of the reaction, the product is going. We know that the carbon dioxide is the gas that we excrete, the gas that we exhaled. So now it's still a gas, but then now it's different from what we started with. The O2 is what we inhale, but the CO2, it is what we exhale. And the subscripts, as we can see there, we're saying that we have 1 carbon atom, we have 2 oxygen atoms, and we still have 1 carbon atom on the right-hand side and still 2 oxygen atoms on the right-hand side because of that subscript. That 2 as a subscript tells us how many atoms of oxygen we have. Furthermore, a chemical reaction is a process in which atoms are rearranged to produce new substances. As we have said, a chemical reaction, basically we are rearranging the atoms that we start with at the beginning of the reaction. We are rearranging the arrangement of those particular atoms, and then to arrange them to make something totally different from what we started with. Now that is going to be our chemical reaction, and as you can see that the properties of the products are going to be different from the properties of the reactants, of the substances that made the product to begin with. So the chemical reaction rearranges the atoms of the reactants to create different substances as product. As we can see from this picture, we are starting with a certain arrangement, but at the end of the reaction, after the chemical reaction has taken place, the arrangement is going to be different. So we are starting with the two reactants, but then at the end of the product, after the reaction has taken place, the arrangement is different, but we still have the very same two products and still the very same number of atoms on the left-hand side and also on the right-hand side. So before we go to the next item or the next concept, we're just going to go for a short break, and I will see you just after this.